Okay, I hope you tried it and it worked okay for you. So let's go a little further. So I divided my screen in two parts vertically so that I can show you here the function, the first function we want to implement in CoCoALib. So the function we want to implement must go before the call of program. And I just copied from another Windows, so I don't waste much of your time copying things and typing. And so I made a slightly different look for it, but I want to show you that this function does essentially what the old reducer index does. So this function, I call it find reducer, just because this is already available in an example in CoCoALib, which is called x minus nf normal form. Yes, in the list of examples, you can already find it there. So I didn't want to change it too much from what is already available in the distribution. So this function returns a long. One of the decision we took for CoCoALib is that every machine number is a long. So we don't need to decide, because it's dangerous, to have an int or a long unsigned int and so on, because we you could save some minor bits, but there's a high risk that you have overflows and you cannot control it. So every number in CoCoALib machine number is a long. So so this function we return along the lines, our coding conventions, and then we take two arguments, which are f and l, where f is a polynomial, and we call it a construct Ringelm, which allows us to have it a fast call like a reference, but highlighting it is constant. We're not going to change the value, even though we call it by reference. And then we do the same, but this is in the official way. Let's see if I can move this line. No, I can't. I could before I started recording. I cannot do it now. Let's do it like this. So, and we take a vector of Ringelms. So as I take a vector, I call it V instead of L. It's more usual. And then let's go back to the division in 3. Okay, and we see here that we had this first control that if the polynomial is 0, then return 0. So first of all, we must return -1 because 0 in C++ is a valid index. Remember that in C++ indices go from 0 to n-1, when in CoCoA 5 they go from 1 to n, which is more natural as a human. And the syntax here, I could write f equals 0, but I wanted to highlight this function is0, which is a function that works very well in all contexts. So I can ask if an ideal is 0 or other things. I can ask if 0, whereas f equals 0 is always a comparison between an object and the number 0, a computer number 0, which is a trickier setting. I have to be careful with the types when I work in C++. So the first line written in C++ is this. So I return -1 if the polynomial is 0. And then the for loop is written in the C++ manner. So long J is running index. It goes from 0 to the length of V. So it goes up to when J is strictly smaller than the length of V. And it increments by doing ++J. And then you see this line is very similar to this line. Remember that you have to put the round parentheses around the predicate. And then if is divisible LPP of F, LPP of the jth element in the vector, return J. And if you get out to the end of this for loop without doing nothing, then you just return -1. Okay, so now we can do the call as we did before. So we do cout. It was called find reducer. Of F, comma, and I can do this. I show you this ring lems. This is interesting. Maybe not the most clever thing in this case, but I want to show you this syntax. Okay, and I can do the checks and the okay, and then I can copy the other examples that we did. I can do this. So cout. So this should return. This one should return 1, and this one should return 0. So let's see. Let's compile. And let's run it. Okay, of course, this returns 0 because the first index is 0, and this returns -1 because there is no divisor in that list, in this list here, which in C++ is this list here. Let's make another LittleProj.